Okay, the last section in this chapter, besides the review, is 1.5 Unconditional Statements. Now, good news and bad news about this section. The good news is that the video is short. The bad news is you're going to have to do a lot of pausing and writing because there's a lot of writing here. But I've pre-typed it all, so you don't have to sit there watching me write slowly, and you know how messy my writing is. So anyway, get ready to hit the pause button. So we're going to learn about different types of statements. The first type is a conditional statement. And a conditional statement is a statement that is written using if and then. So quite simply, there's two parts to this statement. One part's called the hypothesis, or it's the assumption, and this always follows the if part. And then the other part's called the conclusion or the result, and that follows the then part of the statement. So a conditional statement may be true or it could be false. And an example of a conditional statement is something like this. If you were late, so here's your hypothesis right here, you being late. If you were late, then you get a detention. This is the conclusion or the result right there. So if you were late, then you get a detention. Is this true or false? Well, I guess it depends on whose class you're in. If it's in my class, it's probably not true. I don't often do that, but I don't know. Lots of older teachers, like when I went to school and stuff, this was true. If you were late, then you got a detention. So I guess for some teachers this is true, and for other teachers this is not true. So kind of nicely shows that conditional statements can be true or can not be true. Okay, so what if you wanted to test to see, well, you know, I'm not sure if it's true or not. And you'd have to look at 4 different conditions. One condition, for example, is when the hypothesis is true. I'm just going to put T. When the hypothesis is true and the conclusion is also true. So what would that look like? If the hypothesis is true and the conclusion is true, that would mean that you were late. This is true, you were late, and you also got a detention. I have no idea why you can't see all that, but there you go. You were late and you got a detention. So if that happens, you're late and you got a detention, then is this statement true? Yeah, absolutely. This statement says if you were late, then you got a detention, and what happened is you were late and you got a detention. Yeah, this is obviously a true statement. Okay, what if the hypothesis is true and the conclusion is false? What would that look like? What would that mean? Well, what that would mean is you were late, the hypothesis is true, but the conclusion, the result, is false. In other words, you didn't get a detention. You were late and you did not get a detention. Is this statement true then? If you were late, then you got a detention? No, this is false because you were late and you did not get a detention. This is false. This statement is not true in that case. This would be like in my class, right? You were late and you did not get a detention. So therefore, this statement right here does not hold in Mr. Wadger's class. But in other teacher's class, it probably does. That would be like the top row. Okay, now these next two kind of confuse people sometimes. What if the hypothesis is false? And let's actually start by looking at this one. The conclusion is also false. What would that look like? Well, that would look like you were not late, because this is false, right? So this is false. You weren't late, and you didn't get a detention. You were not late, and you did not get a detention. So is this statement in red here, is that still okay if this happened? Yeah, this statement says if you were late, then you get a detention. But you weren't late, and you didn't get a detention. That makes sense. You weren't late. Why would you get a detention? So this one is also true. This does not, the hypothesis being false and the conclusion being false does not make this statement false. Okay, now the one that confuses people all the time. Be extra careful here. If the hypothesis is false and the conclusion is true, what would that look like? Well, that would be like this part's false, so you were not late, but this part's true. You did get a detention. Okay, you were not late and you got a detention. Does that statement, does this case right here falsify what's in the red box here, the red square here? Or sorry, the red rectangle here. Does it make it false? Got your answer? The answer is no, it doesn't. That doesn't make it false. It still can be a true statement. How come? This is saying that if you were late, then you get a detention. This one's saying you weren't late and you got a detention. Is that still possible? Sure, maybe you punched someone in the head in the middle class or something and you got a detention. You weren't late and you got a detention. But that doesn't violate this rule. right? People mistakenly think it works both ways. Oh, if you were late, then you got a detention. That means if you got a detention, you must have been late. It doesn't always work that way. We'll see down below that sometimes it does, sometimes it doesn't. But this is the classic mistake in arguments, that if you have this if-then statement, people just assume it works the other way as well. Okay, so be very careful about that. So you see, the only one that actually falsifies the statement is the second one right here, where you have a true hypothesis but a false conclusion. Everything else is fine. Okay, the next type of statement is a converse statement. So a converse statement is formed by interchanging the hypothesis and the conclusion in a conditional statement. So for example, if we look back here at this statement in the red box, if you were late, then you get a detention. The converse is you just switch them around. You put the conclusion into the hypothesis position and the hypothesis into conclusion position. So you're going to get, if you get a detention, then you were late, is what the converse would be. If you got a detention, then you were late. Okay, so let's go back and let's say that this was a true, let's say it's not Mr. Wadge's class, this is some old school teacher, and let's say this is true, that if you were late, then you get a detention. Happens every time. You're late, you get a detention. Late, get a detention. So now I want you to look at this statement. This is the converse. Is this true? If you got a detention, then you were late. Is that true? Is it necessarily true? Not necessarily. This is a false statement. How come? Well, again, it's just like the example I gave. Maybe you were cheating on a test, so you got a detention. Or maybe you swore at the teacher. Heavens, that's terrible. Then you would get a detention. So there's lots of reasons you could get a detention, even if you weren't late. But this statement says if you were late, you definitely get a detention. So this one's true, but this one is not true. This is false. Okay, next is a biconditional statement. A biconditional statement is a statement in which both the conditional statement and its converse are true. In other words, the conditional statement up here and the converse, what we just talked about, they would have to both be true. So obviously this is not a biconditional statement because its converse was false. If it is a biconditional statement, by the way, you can combine the two into an if and only if statement. Okay, what if and only if means in logic and mathematics means it works both ways. The conditional statement works and the converse also works. So let's work through this. Let's first of all just look at a conditional statement. So this here is our conditional statement. And what it says is, I mean, you can read it, but it says if a number is even, then it is divisible by 2. Is that true? Yeah, every even number can be divided by 2. It's pretty much the definition of even numbers. So this is a true statement. Now, what would be the converse of that? Remember, for the converse, what you're doing is you're putting the conclusion into the hypothesis position and vice versa. So what you'd get is, if a number is divisible by 2, then it is even. Is that true? Yeah, if you can divide a number by 2, it's even. So this is also true, which means, since both of those are true, this is a biconditional statement. And the way you combine those two statements is by using an if and only if statement. And the if and only if statement would be, oh, therefore I have, if a number is even, that should say is, a number is even if and only if it is divisible by 2. And what that if and only if means, it means it works this way and also works the other way. A number is even if it is divisible by 2, and a number is divisible by 2 if it is even. Okay, it works both ways. And in fact, in logic, I remember in university doing this stuff with logic, which I loved, and we actually used that. Instead of just spelling if, we actually spell it IFF sometimes, and what the IFF meant was if and only if. We have one more to go, and it is a contrapositive statement. What a contrapositive statement is a statement that's formed by taking the converse of the conditional statement and negating both the hypothesis and the conclusion. So you first of all take the converse. Remember, oh, I hate it when this happens. Remember our converse was if you got a detention, then you were late. So first of all, we started with the conditional statement. If you were late, then you got a detention. Then we wrote the converse. If you get a detention, then you were late. And for the contrapositive, you take this hypothesis and this conclusion, and you negate them both. You make them both not. So it's going to be if you did not get a detention, then you were not late. Okay, so let's write that down. If you don't get a detention, or did not, or don't get a detention, then you were not late. That's the contrapositive. So remember, we're dealing with a class, an old school teacher, where every time you're late, you definitely get a detention. So is this statement true then? It says if you don't get a detention, so you didn't get a detention, then you were not late. Is that true? That is true, because if you had been late, you would have definitely gotten a detention in this old school teacher's classroom. So if you didn't get a detention, there's no way you were late. You'll notice soon enough that conditional statements, so that was the original statement back here, right here, if you were late then you get a detention. Statements like that and the contrapositive statements are equivalent statements. So in other words, they're either both true or they're both false. It's not possible to have a contrapositive statement to be false and a conditional statement to be true, or vice versa. Either the conditional statement and the contrapositive statements are both true or they're both false. Okay? Alright, here's a couple questions. Consider the following statements. So here's two statements. I have one here and I have another one down here. These are the two we're going to work on. And for each of those we have to do four things. We want to write the conditional statement and determine whether it's true. We want to write the converse and determine whether it's true. We're going to state whether the statement is biconditional or not, and we're going to write the contrapositive statement and determine whether it's true. Okay, so conditional statement is the if-then statement. So this first one here says an equilateral triangle has three equal sides. What would be the if-then statement? It would be if a triangle is equilateral, then it has three equal sides. Is this true? Is it true that if a triangle is equilateral, it has three equal sides? Yeah, that's pretty much the definition of equilateral. So this is true. Okay, now we're going to do the converse. So remember, for converse, we switch the hypothesis and the conclusion. So it's going to be if a triangle has three equal sides, then it is equilateral. Is that true? If a triangle has three equal sides, is it definitely equilateral? Yeah, there's no other possibility. So this is also true. C, state whether the statement is biconditional. Well, if you get a true and a true here, that means they're biconditional because it works both ways. So the answer to this would be yes, it is biconditional. And then what I want to do is write down the biconditional statement. So remember, this is where we use the if and only if. So I guess what we would say is a triangle is equilateral if and only if it has three equal sides. A triangle is equilateral if and only if it has three equal sides, which means it works both ways. And we've already shown in A and B that it does work both ways. Okay, D, write the contrapositive statement. So what we do for the contrapositive is we take the converse, which was B, right? We take this statement here, and we negate both the hypothesis and the conclusion. So it would be, if a triangle does not have three equal sides, then it is not equilateral. If a triangle does not have three equal sides, then it is not equilateral. What do you think about that? True or false? Yeah, that's true. If a triangle does not have three equal sides, we do not call it equilateral. So notice, as I said before, that this answer here and this answer here are always going to be the same. The conditional statement and the contrapositive are either both going to be true or they're both going to be false. Okay, let's do one more of those. So the first thing we're going to do is write the conditional statement. Here's our little statement, and we're going to write it in the if-then form. A number that is divisible by 5 has a 0 as its final digit. So our if-then statement would be, if a number is divisible by 5, then it has 0 as its final digit, or something like that. If a number is divisible by 5, then it has a 0 as its final digit. Exactly. Okay, so is this true or is this false? Think about that for a second. If a number is divisible by 5, then it has a 0 as its final digit. That's false. How come? Can you think of a number that is divisible by 5? So remember, the thing that makes it, when we looked at that table before, again, I'm going to have to click on a whole bunch. Oh, right here. The thing, this green one right here, the thing that makes it false is if you have a true hypothesis but a false conclusion. So in this case, this would have to be true. The first part right here would have to be true. So we have a number divisible by 5. That's true, but we want false that it does not have 0 as its final digit. Can you think of a number like that? That you can divide by 5, but it doesn't have 0 as a final digit? Sure. You can think of any number you want as long as the last number is 5. For example, 25, right? That's divisible by 5, definitely. 5 times 5 is 25, but it does not have 0 as a final digit, it has a 5 as its final digit. So what this is called, when you find an example that proves this is wrong, this is called a counterexample. And I think we talked about this last year in Foundations 11. A counterexample. You only need to find one counterexample. As soon as you found one counterexample, then you've proven that this is not true. The statement's not true. Okay, so let's move on. We can still go on with this question. The next thing we're going to do is write the converse and determine whether it's true. So the converse, remember, we're switching the hypothesis with the conclusion. So you would have, if a number has 0 as its final digit, then the number is divisible by 5. Is that true? So think about what's being said here. They're saying any number that has a 0 as its final digit is divisible by 5. Is that true? It certainly is. So even though the conditional statement was false, in this case the converse is true. So now we're on to see, is the statement biconditional? Biconditional means that both of these would have to be true. Well, that's pretty obvious then. It is not biconditional. So the answer is no. And D, the final question. We want to write down the contrapositive statement. So remember, for the contrapositive, we take the converse and we negate both parts of it. So it would be, if a number does not have 0 as its final digit, then it is not divisible by 5. If a number does not have a 0 as its final digit, then it is not divisible by 5. Okay, is that true or not true? Well, let's think about it. If a number does not have a 0 as its final digit, then it is not divisible by 5. That's false. How do you know that that's false? Well, we need to have another counterexample. Let's see if we can think of a counterexample. It turns out it would be all the same counterexamples that worked up here. So 25 would be another counterexample, but think of a different one. Again, it's going to be any number that ends with 5. How about 35 this time? If a number does not have 0 as its final digit, yeah, that does not have 0 as its final digit, then it is not divisible by 5. But wait a minute, that is divisible by 5. So this is a counterexample, and it proves this is false. And again, we're not surprised about that, because we said that the conditional statement and the contrapositive should always have the same. In this case, they were both false, and up here, that's supposed to point to there, and up here, we had them both true, even though you can't see them anymore because of this silly thing. There must be a way to turn that off, and I really should do it so I don't have to keep clicking everything. But you could see they're both true up there, they're both false down here. There's no other possibility. Either both true or both false. Okay, I hope your wrist isn't too sore from all that writing, and you probably gave the pause button a really good workout there. That's it. Next class, I guess we'll be doing review. I hope you enjoyed this chapter as much as I did. Love this stuff. Best class I ever took at university, perhaps, was formal logic, and it had lots of this stuff in it. Okay, see you soon.